Hello, hello,
Yes, sir.
hello, students. Hello.
Yes, sir.
Is it clear? My voice is clear.
Yes, sir.
Okay,
Yes,
okay. Is the screen visible? Hello.
Yes, sir.
Clear, na? Okay.
Yes, sir.
So today we'll be seeing the revision of unit number 1. So those who have missed some of the lectures in between can get through easily, and you can understand what is there in unit number 1. Today we'll be also seeing some of the assignments that will be given on unit number 1. So we'll start with the initial, what is Internet of Things. So it is the system architecture that has been revolutionized communication and methods by allowing various computer networks around the world to interconnect. And we have already discussed what is thing. It is the physical object called as thing, or a person, or an idea. Internet of Things can be overall defined as a network of physical objects or a person called things that are embedded with software, electronics network, and sensors that allows these objects to collect and exchange the data. That means clear cut what we can say, that Internet of Things is nothing but collection of physical objects or the person that are being clearly with embedded with softwares, electronics, and network, and that allows to collect and exchange the data within themselves. So this is what is called as Internet of Things. We can also define in the other way as it is a highly distributed network of smart objects embedded with electronic sensors, actuators, and softwares, each capable of dynamically generating, analyzing, and communicating intelligence that can be used to increase the operational efficiency and power new business models and make life more easier and comfortable. So it is all about nothing but the devices that will be talking with each other with the help of some kind of networking, and which will provide you different kinds of applications. The goal of IoT is to extend the internet connectivity from standard devices like mobile computers, etc. The introduction to IoT is the IoT makes virtually everything smart by improving aspects of your life with the power of data collection, AI algorithms, and networks. Over 9 billion things, that is physically objects, are currently connected to the internet. Things in the IoT sense is the mixture of hardware, software, data, and services. This is a very important line. So IoT is nothing but the mixture of hardware, software, data, and services. Simply putting, we can also say that the concept is basically connecting any device with on and off switch to the internet. This also includes everything from cell phone, coffee makers, washing machine, headphone, lamps, wearable devices, and almost everything that you can think of. So all these devices or the objects can be connected with each other. They will be exchanging the data within themselves, communicating, so that you can have an application development with the help of IoT. The connectivity, networking, and communication protocols used with these web-enabled devices largely depends on specific IoT applications deployed. IoT can also make use of artificial intelligence and machine learning to aid in making data collecting process easier and more dynamic. So I've already said that Industry 4.0 is nothing but the combination of artificial intelligence, machine learning, and IoT. So all these things will come together to make the data collection process more easier, and the analysis uh, analysis of the data much more easier and dynamic. IoT means taking all the things in the world and connecting them to the internet. That's what I said, that all the devices can talk with each other with the help of internet. When something is connected to internet, that means it can send information or receive information or both. And the ability to send and receive information makes things smarter. IoT is also about well-being, informed to make timely and better decisions. So if you're going to collect a lot of data from lot of billions of devices all together, so that will help you to analyze each and everything, and that will help in taking the better decisions. This is the IoT reference model which is suggested by Cisco. So it is having a 7-layer, right from physical device, connectivity, edge computing, data accumulation, data abstraction, application, and collaboration. So in the first physical device and controller, which will be having the object at the layer 1, which we send to be as sensors, devices, machines, etc. Then it will be connected through connectivity. Then it will be useful for data element analysis and transformation. Then this data after analysis will be stored. Then it will be accessed. Then it could be useful for analysis, reporting and control, and then collaborating by involving people and business process. So developing a new model, new business with these 7 layers. So IoT reference model by Cisco suggests these 7 layers which will be working with each other, interconnected with each other. Just a moment, some slides. It is so we were on this. That is nothing but the IoT reference model by Cisco. So the next slide will be IoT conceptual framework. So the framework can be of 3 types. The first one is a physical object plus the controller sensor and actuator plus internet, which will make the IoT umbrella. Then the second concept will be to gather, enrich, stream, manage, acquire, and organize. So that will be again the IoT framework, which will be useful for data center and enterprises. So gathering means all the collector raw data is collected. Enrichment means collecting the data and making it quality, then streaming it, managing it, acquiring it, and then organizing it. And the third conceptual framework is nothing but to gather and consolidate, connect, collect, assemble, and manage Internet of Things. That is for the cloud services. Then next comes the IoT architecture. So it's a very simple diagram of IoT architecture. You can see at the bottom of the diagram, there are different sensors and controllers being connected together to the internet via gateway. So through gateway, it has been the local area network, or it may be and wireless area network, through which these sensors will be connected to the internet and they can talk with each other. Then the next part is the major components of IoT. There are 5 components of IoT. Is it, students, are you understanding it? Hello? Hello? Hello?
Yes, sir.
Okay. So 5 major components are of IoT is there. The first one is things or devices that with the object that is connected. Then second one is the gateway. Third one is a cloud. Fourth is the analysis, and fifth is the user interface. All these 5 things together are nothing but the major components of IoT. Now let us start the first block, which is nothing but the physical device or the sensors, or I could say that the smart devices that are connected, because they will collect the information and will give it to the next state. So devices and sensors are the components of the device connectivity layer. These smart sensors are continuously collecting the data from the environment and transmitting the information to the next layer. So these are the sensors which will be connected around, that may be connected to the brain, heart, that may be collected to get the various information of body mass index. It might be anything. So it might be a body, it might be any kind of object like a humidity sensor, temperature sensor. So various kinds of sensors can be connected, and these information will be collected and given to the next layer. Latest technique in the semiconductor technology is enabling the micro smart sensors for various applications. So you can see that latest technology of semiconductor technology is developing micro smart sensors that could be used in various applications. The common sensors that are normally used are temperature sensors, pressure sensors, humidity or moisture level, light intensity detectors, moisture sensors, then comes the proximity detection, RFID tags, etc. These smart devices and sensors can be connected to the low power wireless networks such as Wi-Fi, Zigbee, Bluetooth, etc. Each of these wireless technologies has its own pros and cons in terms of power, data transfer, and overall efficiency. So these wireless technologies, having wireless network, is having some kind of advantages, the other is having some kind of disadvantages. So according to the application, you can select whether Wi-Fi, Zigbee, or Bluetooth. Developments in the low power, low cost wireless transmitting devices are promising in the area of IoT due to its long battery life and efficiency. So why these wireless networks are preferred? Because they helps in a long battery life as well as low power as well as low cost, making these devices, these network, wireless network, to be used in these smart devices and sensors. Now the next block will be gateway. So gateway is nothing but it is the block between the internet and I could say between the sensors that are being used here. So you can see that the gateway is in between that sensor and the cloud protocol or cloud platform. So sensors, it will be given to the Arduino. From Arduino, it will be given to the Raspberry Pi, and from Raspberry Pi, it will be given to the IoT platform. So in this case, the Raspberry Pi will be nothing but your gateway, that is between the Arduino and your IoT platform. Gateway actually manages the bidirectional data traffic between different networks and protocols. Another function of gateway is to translate different network protocols and make sure interoperability of the connected devices and sensors. Gateways can be configured to perform pre-processing of the collected data from thousands of sensors locally before transmitting it to the next stage. So actually gateway collects the data from the input sensors, from the different kind of objects, and then these is collected together and it is processed, and then it is given to the next block, that is next stage. IoT gateway offers certain level of security to the network and transmitted with a high order encryption technique. So it not only gathers the data, collects data, organizes the data, pre-process it, but at the same time it also provides a security through the encryption technique. It acts as a middle layer between devices and cloud to protect the system from the malicious attack as well as unauthorized access. After gateway, the third block is cloud. Internet of Things create a massive data from the devices, applications, and users, which has to be managed in an efficient way. IoT Cloud offers tool to collect, process, manage, and store huge amount of data in real time. Industries and services can easily access the data remotely and make critical decisions whenever necessary. So actually cloud, what does it, that it offers to collect the process, it offers to tools which actually helps to collect the information from all the objects, then it processes, manages, and store this huge amount of data in real time. So this is the huge and very hard task to carry out. Basically, IoT Cloud is a sophisticated high-performance network of servers optimized to perform high-speed data processing of billions of services, traffic management, and deliver accurate analytics. So it not only collects the information from these devices, but it processes them. And after processing these billions of information collected from the device, it also manages the traffic between the two sides and then deliver the accurate analytics. Cloud system integrates billions of devices, sensors, gateways, protocols, data storage, and provides predictive analysis. Companies use this analysis data for the improvement of products and services, and preventive measures for certain steps and build their new business model accurately. Distributed data management systems is one of the most important components of IoT cloud. Then this is the cloud architecture. So you can see that there are two parts of cloud architecture. One is the front end and the other one is the back end. So in the front end, you can see that there is an internet and client side infrastructure. So the user side, this front end is the user side with the availability of internet, and back end is nothing but having the blocks like management, storage, service, applications, and security. So front end is used by the client. It contains a client side interface and applications that are required to access the cloud computing platform. The front end includes the web servers like Chrome, Firefox, then Internet Explorer, etc. Backend is used for the service provider. So front end is visible to the user, but backend is not visible to the user. So whatever you have been working on, different programs, all the kind of strategies that you are making will be at the back end, and front end it will be displayed. So whatever the whole service is being carried out is at the back end. It manages all the resources that are required to provide cloud computing services. It includes huge amount of data storage, security mechanism, virtual machines, and deploying models, servers, traffic control mechanism, etc. So at the client side, there will be client infrastructure in front end components. It provides GUI to interact with the cloud. Then the backend will be having the application. The application may be software or platform that the client want to access. The third one is the service. A cloud service manages that which type of service you access according to the requirement. A runtime cloud provides an execution and runtime environment to virtual machines. Then storage is one of the most important components of cloud computing. It provides huge amount of storage capacity in the cloud to restore and manage the data. Now, storage is one of the most important component of cloud computing, which provides huge amount of storage capacity in the cloud to store and manage the data. Then comes infrastructure. To provide service on the host level, application level, and the network layer, cloud infrastructure includes hardware and software components such as servers, storage, network devices, virtualization software, and other storage resources that are needed to support the cloud computing model. So if I want to implement this cloud infrastructure, I need to have a very sophisticated infrastructure to provide that. Otherwise, you cannot provide the service if the infrastructure is not there. So, in providing the infrastructure and giving the services will make the cloud as one of the most important aspects. Then comes management, that is used to manage components such as application, service, runtime, cloud, storage, infrastructure, and other security issues in the backend and establish coordination between them. So management is nothing but coordinating all the blocks together in order to provide the service. Security, as I said, that cloud architecture provides an inbuilt backend components of security, that is having the mechanism for data encryption at the backend. Then the internet is the medium through which front end and back end can interact and communicate with each other. Then the next block is analysis block. Analysis is the process of converting the analog data from billions of smart devices, sensors. They will be collected together, they will be pre-processed together, then they will be sent on the cloud, they will be stored there, and they will be analyzed there. So overall, what we are saying that the whole data that has been collected, which is stored at the cloud, which is managed at the cloud, is now can be used for analysis purpose. So this analysis will help you to take decisions better and also building up the business models. So small analytics solutions are inevitable for IoT systems for management and improving the entire system. One of the major advantages is in real-time small analysis. Information is very significant for business model and predictive analysis in case of business. Then after analysis, it will be user interface. The user interface are nothing but the user side, which will be taking the service up. So user interface are the visible and tangible part of the IoT systems, which can be accessible by the user. Designers will have to make sure that it is a user friendly. Otherwise, what happens? You can see the difference between a window or the other operating system is that window is by far the user friendly, and hence it is preferred more as compared to Linux or Unix operating system. So user friendly things has to be very important in this. User interface design has a higher significance in today's competitive world. It often determines the user whether to choose a particular device or appliance. User will be interested to buy new device or smart gadgets if it is user friendly and compatible with common wireless standards. Then if you are having all these things together, what the first is the object or the devices or the sensors, second one is the gateway, third is the cloud, fourth is the analytics, fifth is the user interface. In between all these things, what is going to be a common factor is the communication system. Once they communicate with each other, the data can be transferred from one side to the other side. So communication means exchanging the information between source and destination. So it consists of protocol handlers, message queue, and message cache. A device message queue will be inserted to the message. Okay, I'll go in a very simple way. What is going to happen is that if I want to send the message, these message will be converted into packets. Now the packets will be having the header numbers like 1, 2, 3, 4, 5. So the packet which is been given header number 1, it will be first sent to the other side, then second will be sent, then the third will be sent. So the first one will, which is entered, will come out as the first also. So first in first out kind of a thing happens here in the communication. So all the packets which are been divided in, of the messages will be sent one by one, and they will be in the queue. A device message cache stores the received message. Representational state transfer, that is REST, architecture style can be used for HTTP access, GET, that is graphic editor toolkit, POST, that is power on self-test, PUT, programmable unijunction transistor, and delete methods for resources and building web services. So these are the architectural style that can be used for transferring the information. The communication link that is used in IoT may be wired or wireless. If in wired, mostly there is two types, that is in serial and parallel. For longer distance, you can prefer serial communication. And the serial data transmission and reception can be done in the form of I2C, SPI, that is inter-integrated circuit, and serial peripheral interface. So this is what the communication system is about. Then we'll go to the example of IoT. So we have seen, I have already explained this example. Example of IoT is the best way the street light in the city. So let us assume that there are a group of 8 street lights on one side and 8 street lights on the other side. So overall there will be 16 street lights. We'll make it in group 1 and group 2, group 3, group 4. These all informations like first group and 2, group 1 and group 2 will be given to the group 1 and 2 controller. Group 3 and group 4 information of the street light will be given to the group controller 3 and 4, and then these informations will be given to the internet for the central command and control system. So you can see that the street light in the city can be function like a living entity by sensing and computing using embedded system that can communicate and interact through central control and command station. Assuming the 16 street light comprises of all the sensors, and the data will be collected at the controller, and from there it will be given to the internet. Each group can be connected to the controller through Bluetooth or Zigbee, and then it will be connected to the central command. Now the next section will be of the applications. So we have seen yesterday in yesterday's lecture what are the applications of Internet of Things. The first one is the wearable. So I could say that wearable is one of the thing that has been going nowadays, a trendy thing, like all the smart devices that are enabled with like it might be the smartwatch, it might be the Fitbits, it might be the heart rate monitors, the smart watches, and even your mobile phones that are being connected with you. All these variables are because of IoT. These are the all applications of IoT. One of the lesser known variables including Guardian glucose monitoring device is also there. Then the devices for the AIDS suffering people from diabetes detects a glucose level in the body using a tiny electrode called as glucose sensor under the skin, and this relay this information via radio frequency to the monitoring device. So each and every information you can get through a smart device that has been attached with you, and that could be given the information to the monitoring device. So all these things is possible only because of IoT, which is an hallmark IoT application, that is the wearables. Then second is the healthcare. IoT applications can turn reactive medical based systems into proactive wellness based systems. So all the health issues like body mass indexing, all the health related issues will be collected. The information regarding the body will be collected, and then it will be processed. It will be examined, analysis by the physician, so that they can take the decision whether what kind of method could be applied, what kind of things to be gone for the next stage. So the resources that current medical research uses lack critical real world information. It mostly the leftover data, controlled environment, and volunteers for medical examination. IoT opens way to a sea of valuable data through analysis, real time field data, and testing. The Internet of Things also improves. The Internet of Things also the improves the current devices in power precision. So, like if I want to say that, if I want to have the power devices, so that could be easily done with the help of this. Just a moment. So the Internet of Things also improves the current devices in power, precision, and availability. Precision is the by far the most important thing, because even if it is available, how precisely it gives an output is depending upon the accuracy. So IoT focuses on creating system rather than just equipment. So you can see that from the block diagram, it is clear that there is a care device. It is going to be given to the smart gateway. Then from gateway it will be given to the cloud, and from cloud it will be given for the display purpose. So all these things are in the healthcare. Now IoT will be also very much useful in developing smart cities. Now, according to the information, it has been clear cut that nowadays there are different global issues in the city, that may be clean drinking water, deteriorating air quality, increasing the urban density, and also the different intensities across the city. So each city is having different issues. So according to those issues, you can develop those applications that will be helpful. Like it might be water management, waste control, and emergencies with the town planning. So smarter cities can be made more smarter with the help of IoT. Then the next part will be the agriculture part. So nowadays we are being moving towards a greenhouse farming technique, because that will yield the crops by controlling the environmental parameters. So you can see that the agriculture can be enhanced with the help of the information that can be collected through sensors like humidity sensor. It may be water level sensor. It may be the detecting the diseases of the plant, like all those things that are related well for the development of the plant. So you can concentrate on each plant in the field, so that you can come to know that what kind of diseases are to that plant, what how much less water is there, what is the moisture. All these conditions can be analyzed, and how this could be analyzed by controlling the environmental parameters. So once you get the temperature, once you get these parameters, you can easily improve them. For example, most of the times the temperature is also very much important, because manually handling and because of the higher temperatures, you will be finding the production loss, energy loss, or the plant may die because of high temperature also. So by controlling that temperature, what is required for the plant, you can also control the environmental parameters. So a greenhouse with embedded devices not only makes it easier to be monitored, but also enables us to control the climate inside. Sensor measures different parameters according to the plant requirement and send it to the cloud. It is then processed the data and applies to the control action. So according to the all the environmental parameters will be sensed by the sensor, and the whole information will be given to the next stage, where it can be processed, and then the controlling parameter can come into the picture. So you can see the example that from this example, it has been clear that sometimes you know that if you want to switch off the motor that has been taking out the water from the well, Now the water is being given to the plant, and you come to know that now enough water has been given to the plant and you should switch off the motor. So you can directly switch off the motor with the help of your mobile. So sitting at home you can switch off, you don't need to go to that switch button and then you press it. So on and off connectivity can be done with the help of phone. So agriculture can be moved on to the advancement. It is moving to the advancement, and with the help of IoT, it can be improved a lot. Then comes the industrial automation. With IoT applications, one could even re-engineer products. They are packaged to deliver better performance in both cost and customer service experiences. IoT here can prove the game changing with the solution for all the following domains like factor digitization, product flow monitoring, inventory management, safety and security, quality control, packaging optimization, logistic and supply chain management. So if you want to say that I am having an automation industrial, we are moving to the very serious industrial automation. At that time you have to go for these solutions in order to improve the following domains. So if you're going to improve these domain, then you can go for the industrial 4.0. So a lot of new things are coming in the industrial automation. So all the routine kind of automation it will change now, and when these parameters like IoT, machine learning or artificial intelligence will come into the picture. Then the next application is in the smart grid. The IoT smart grid solutions serve today's energy demand. So now, if as far as the population is concerned, we know that electricity and energy demand has been more. So in order to live up to that expectations, you need to have a smart grid. They could have an practical solutions to balance out increasing complexity of energy distribution networks and achieve real-time visibility into consumption process. To comply with advanced production process, energy sectors are progressively collaborating with IoT technologies in order to go for a smart grid ecosystem. So smart grid can be easily improved with the help of IoT. So we can say that you can make an IoT smart grid solutions in order to fulfill the energy demand. Then the next part is the smart supply chain. The IoT technologies offer a practical approach to take the supply chain management to the next level. The logistic transportation industries have started leveraging comprehensive IoT solutions to manage good from anywhere at any time at global scale. So supply chain management is like supplying the good from one part to the other part, but if that manually it becomes very difficult. So with the help of IoT we can manage those goods also from anywhere at a global scale level. So this is also one of the most important application. And then comes the smart home applications. Now this is going to be quite an interesting application of IoT, because now we are moving towards a smart home. Not only just smartphone, will be having the smart home applications also. Now in these applications you can connect all the devices that is at your home, like it may be fan, your bulbs, then your refrigerator, your washing machine. All these smart devices, you have to first make them smart, and all these smart devices can be connected with your mobile. So you can come to know all the information of these devices on your mobile phone, like what kind of temperature is there in the house with the help of AC, which kind of devices is on, which is not off, or what kind of things are present in the fridge, what kind of clothes are available in the washing machine. So all these applications that are been surrounding with these devices, the smarter devices, you can connect with the mobile, and that will make all IoT as a smart home application. So this is the application of the IoT. So we have taken in all different domain all these applications, and I hope that we have covered all the points in unit number 1. And I hope that you have understood. If any questions, please you can ask for. Hello. Hello students, have you got it? Hello.
Yes, sir.
Hello. Hello students. Hello, have you got it? Hello.
Yes, sir. Yes.
Okay, okay. So I will be giving you the assignments. Uh, yes, I will be giving you the assignments on this unit number one, and you have to do that assignments. We'll take the attendance. Roll number one,
Yes, sir.
roll number two,
Yes, sir.
three,
Yes, sir.
four,
Yes, sir.
four,
Yes, sir.
five, six,
Yes, sir.
seven,
Yes, sir.
eight,
Yes, sir.
nine,
Present.
10, 11, 12,
Yes, sir.
13,
Present.
14,
Yes, sir.
14,
Yes, sir.
15, 16,
Yes, sir.
17,
Yes, sir.
18, 19,
Yes, sir.
20, 21, 22, 23,
Yes, sir.
20,
Sir,
23.
20, 22, okay, 24,
Yes, sir.
25,
Yes, sir.
26, 27,
Present.
28, 29,
Yes, sir.
30, 31,
Yes, sir.
32,
Present, sir.
33, 34, 35,
Present, sir.
36, 37,
Yes, sir.
38,
Yes.
39, 40, 41,
Yes, sir.
42,
Yes, sir.
43, 44,
Yes, sir.
45, 46,
Yes, sir.
47, 48, 49,
Present.
50, 51,
Yes, sir.
52, 53, 54, 55,
Present. Hello. 53, sir.
53, 54,
Yes, sir.
55,
Present.
56,
Present.
57,
Present.
58, 59,
Sir, 58 present.
58 is present, 59, 60,
Yes, sir.
61,
Yes, sir. Present.
62, 62. Okay. Now, whose number is remaining? Please, you can save. You can give your roll number. Those who have missed the attendance. Yes. Any number missed?
Sir, 26.
Sir.
26.
Ah, yes, sir.
4.
Okay, 26. Next,
4.
4 is there. Okay, next,
31.
31 is there. 34. Next,
Sir, 55.
55 is there. Next, is it okay? Okay. Thank you, students. हा? पीजी विभूते सर एचओडी बाजूला नाही आहे का ते काय द्यायचं आहे का नाही मग ते सही घ्यायची असेल तर त्यांनाच हे करावं. फोन करायला लागले त्यांना